goal is to bridge between computing, art, and education. We want to create a low barrier of entry for people to learn programming and to generate computer graphics procedurally. And these computer graphics can be artworks or have some utility other than just art. For students, they learn some programming concepts by using our platform, and they get visual feedback as they're learning. The feedback's really beneficial to them. In addition, they gain some basic skills with computer graphics if they want to build user interfaces, if they want to create visuals for a game, things like that. And they get to showcase their works in our visual gallery. So we get to showcase on the internet publicly. All the images are cataloged and they have URLs associated with them. So before I can kind of delve into actually looking at the platform, I want to define a few kind of concepts in our context. So we do image generation. Specifically, we're focused on procedural image generation. That's where you step-by-step follow processes defined by the artist or the programmer to generate images. It's not really AI. It's more like you step-by-step are giving instructions for how the image is created. We can end up creating patterns and artworks based on predefined sets of rules. You can visualize diagrams. A lot of diagrams nowadays are generated from code, things like SVG, other formats as well. You can also display a scene. You can display a model, things like that. You could use this for art, video games, design, marketing. There's many applications. But that's what we're talking about when we say image generation. So our platform has two main components. One of these components is our open source creator studio. It is on GitHub. I hopefully will be able to make this URL available, and I think it's available on the composition website. So you could clone our repo and play around with it on your local computer. It runs in a web browser. So you just open it up in the web browser of your choice, and you can run it. There's also a digital gallery on our website at algoart.org. So how do these algorithms work? We call them drawing algorithms. They're written in JavaScript. Every algorithm follows this unified framework. There's an initialize process, a start process, a pause, a reset, and a draw one step process. So the image will be generated step by step. Every step you call draw one step. There's also parameters to customize the drawing process. A little more about the drawing algorithms. Each algorithm has a vast set of parameters. The parameters, as I said, will affect how this step-by-step process proceeds. And our platform loads the parameters and allows you to modify the parameters in real time. So let's actually pull up the platform now that you're familiar with image generation and some of the basic concepts. So here is our Creator Studio. In the Creator Studio, you have different algorithms, drawing algorithms you can select from. I selected the first one, geometric patterns. And there's a parameter set for that algorithm. You can even pull up the code for that specific algorithm. We're working on making it more accessible. Currently, it's not the most accessible to modify the code in browser, but it is possible. Later on, we'll talk about soundification. Our images can be converted into sound as well, which will be interesting. But this particular algorithm, let's start it. Let's click play. You can see it's step-by-step drawing something. You could reset the algorithm. You could clear the canvas. You can even save the image. If you like the image, save it to your computer as a JPEG or PNG file. While it's drawing, though, we can click to turn on or off certain values to change the parameters. So I turned off avoid intersections. Now it doesn't care if a line has been drawn before, it just keeps drawing. I can turn avoid intersections back on. Now every line that's been drawn adds a sort of constraint. You can't intersect previous lines anymore. We could also turn off this discrete angles. Now angles are totally random. We don't have these 90-degree angles anymore. As you can see, it's drawing in all these different directions, filling in much more densely. And we can even go down and adjust the colors. I think these are the colors for this image. Let's modify it. Let's make it red. Let's make it green. Over time, it's kind of alternating between a reddish-greenish color, as you can see. So in real time, I'm just modifying parameters, and it's adjusting the drawing process. It's kind of neat. It's like an auto-drawing tool. It's actively drawing, and you're interacting with it. But let's try a few more algorithms, just so that you can see the variety of things that my students and I have created. Every one of these algorithms has an artist who created it. So this one was designed by a student and I, Alyssa. We were co-artists for that one. This other algorithm, Spiderwebs, was designed solely by my student Maya, trying to replicate spiderwebs. All right, great. So that's enough for the moment. We'll come back to the platform, but let's go to the slides. Okay, so I want to tell you a little bit about some of the algorithms that have been developed and kind of why they were developed and what the students got out of it. So this particular student, Lalith, developed an algorithm called spirals, and they learned about how coordinate systems work. In mathematics, there's the standard R2, where you have the Cartesian coordinate system, but there's also polar coordinates, where you index based on, or you display points based on radius and angle. So they were exploring converting between Cartesian and polar coordinates, and they were generating these spiral patterns. They wanted to replicate this Archimedean spiral, and they had all sorts of parameters. So these images were generated by the same algorithm, just under different parameters, and the student learned about coordinate systems. Here is another algorithm developed by my student Alyssa. Alyssa learned about curves and paths and how to kind of model different curve functions. Her algorithm was called vines, and she wanted to replicate vines and other organic plant life, how it moves and curves over time as it grows. And she created linear, cyclical, sinusoidal, and some various hybrid curve patterns. I had a student, Giovanni, who wanted to replicate constellations in the night sky. Giovanni learned about angles and uniformity in geometry, and doing so was able to replicate these constellation-like patterns. And the process would step-by-step select points and connect them together in various ways based on the parameters. So up here we have these sort of 90-degree angle patterns, but over here we have more triangular-like patterns. I had a student, Maya, who I mentioned already, who wanted to replicate a certain kind of fractal, and she had a lot of fun delving deeper into basically filling smaller and smaller circles into the space that was provided, creating a sort of fractal pattern, as you can see in the left two images. Lastly, Giovanni also created a Voronoi diagram algorithm. This is a concept from computational geometry. And with these Voronoi diagrams, we used experimental metric functions in mathematics, and we actually were able to get accepted and present this at a well-known computer graphics conference. So that was quite an accomplishment for the student. So I'm telling you about this because I want the students who use the platform to learn, advance their skills, and in some cases, they actually generate meaningful research contributions. So that's really what I'm hoping for with this platform. In total, we ended up creating this image data set that you can see online. It has over 8,000 unique images from 15 different drawing algorithms. And we received 23,000 comparison-based reviews to help organize our gallery. We want to figure out what are visually interesting, visually appealing images. We want to figure out which parameters really affect how the image is going to result. And we have a huge amount of data, and we're hoping to do some sort of machine learning project in the future to figure out how those parameters really affect the result. That would be pretty cool, in my opinion, to be able to look at the parameters, be able to predict what the resulting image might look like. So here are some of the images in our gallery from a variety of different algorithms. All right. And I also like this algorithm a lot. This was one I mentioned, or you might have seen in the list before. Alyssa and I made based on this 70 funk style of artwork we were trying to replicate. But I just wanted to show you more images from our gallery because I thought these were cool. All right, so I also wanted to mention we have presented in some fashion shows. If you weren't aware, there is a math fashion show that happens every year at the Bridges Conference. It's an international event, and we've been featured twice in this fashion show. It was really fun. We got to walk down a runway. We had models volunteer to be a part of it, and we showcased with, I think, around maybe 60 or 70 other artists who were exhibiting their fashion lines. But we showed off our designs on hats, shirts, scarves, t-shirts. We even had puzzles. We weren't able to exhibit that, but we've been putting our designs on lots of different items, seeing what works, and getting feedback and reviews from people on our items. So for future directions, one thing we're working on is an online course teaching computer science and programming with visual feedback. That's something we hope to launch in the near future. And we have been exploring visualizing more complex mathematical structures, more complex research-like concepts as artwork. You can both see it and learn about it from the visual experience, but also it has some research or complex value to it. And the last thing, we've been exploring how to soundify our images. When I first started this work, people were saying, oh, it's not just algorithms and artwork, it's algorithms and visual artwork. And I was like, well, maybe it doesn't have to be visual. But people were very particular when I was calling it AlgoArt. And I realized, yeah, we need to make sure that we explore various forms of artwork. So we're exploring sound and audio. And I have a demo of that. So let's try it out. So I turned the canvas into a sort of two-dimensional keyboard. And I'm going to try to draw that for you. Let's see, draw grid. And let's start playing. The algorithm's going to draw, and it's going to play the keyboard. and I can turn on these additional settings. You can sort of get a heat map of where the keys are. But let's actually turn off that. Let's turn up the speed a little bit. I think it's going a little too slow. Let's adjust the drawing pattern. So I actually showed this to a music professor, and I'm sorry it's a bit repetitive. It can get a little annoying, but music has some beautiful repetitive elements to it, and we're approaching music, not quite there. But I showed this to a music professor, and he found this really interesting because the circle keeps getting a little bit bigger, and he was actually talking about a phenomena on piano where when you create progression of notes, sometimes you don't get exact continuous progression, and you have to have discrete jumps in the notes. I'm sorry, the image is blanking. But so that's what you have going on here, is there's a continuous sort of spectrum of notes, but because it's set in this discrete grid, let's turn on the grid. Every once in a while it pops up to the next note, and then the next note, and then the next note, and you get this slight progression. All right, well, thanks for enduring the sound. It's still a work in progress. All right, well, thank you very much. I really appreciate your attention.
Thank you for that presentation, Michael. Does anybody have any questions? Claire, can you bring a mic?
Thank you. I was wondering, how hard is it to make an algorithm for, and also, I guess, maybe, are there any plans to maybe step away from just like code and even have some sort of like drag and drop interface?
Yeah, those are great questions. So the first question, I have had developers I've showed this to, within 5 to 10 minutes, they've created something interesting. I've also had some students who've never done any programming create something interesting in maybe 20, 25 minutes. But the reality is, once you start creating something, you'll get engrossed into it, and you might end up spending a month tweaking it, adding tons of parameters. And so it's kind of how much you get into it, how much you want to put into it will affect whether you have a single image or an entire space of images that you can generate. Because the more parameters, you end up getting in a giant space of variations of the image. So if you put more coding time in, you end up having many possibilities. And then your other question, we haven't done anything with drag and drop, but I have created algorithms where just adjusting parameters can almost create a new algorithm. So if you really put a lot of effort into the parameters, you can just make it checking logic conditions can basically affect the process.
Okay, I was also, is it possible to have algorithms with custom parameters as well?
Yeah. So every algorithm has its own set of parameters. It's actually in the code. You list the parameters, and the UI will detect all those parameters and generate all the user interface checkboxes, text boxes, drop downs. So it's actually a pretty simple thing to add a new parameter in the code. It requires very little thought. It's a very intuitive format.
Any more questions? Do you have a favorite algorithm?
Yeah, I really like the geometric patterns. Well, I'm not wearing any of them right now. These are from some different algorithms, and Chunan is wearing. My girlfriend is wearing some of the artwork as well. But the geometric patterns, there's so many parameters built in that you can go from something that looks like a circuit board you're generating to something that looks like clouds in the sky. And I just love how parameter customization can take you from looking like one thing to looking like something totally different.
Okay. Thank you.